haloalkane, haloalkane, alkyl halide. So this is a symmetrical type of ether. So you can break this is oxygen linkage. You can either break the bond by right side or the left side. किसी भी side से आप break कर दो bond. And to this oxygen के साथ आप क्या attach करवाओगे? Sodium. So that it will form sodium alkoxide, and the remaining fragment will form the alkyl halide. You will attach the suitable halide group, halogen group to this alkyl. So when you attach the sodium Na to this oxygen, ये क्या बनेगा? 1, 2, 3 carbon and this ONA. This is ONA. So this is your alkoxide. Okay, this is your propoxide, sodium propoxide. Plus this remaining group 1, 2, 3 carbon chain, 1, 2, 3 carbon chain, इसके साथ आप क्या attach करोगे? Any 1, 2, 3, any halogen group, chlorine. So I'm just attaching bromine over here. Okay, so that's the reagent. This is the suitable reagent. आपको पता होना चाहिए आप कैसे cleave कराओगे bond को. And to see to this oxygen you have to attach the sodium, okay, in the Williamson synthesis, because Williamson synthesis is basically a treatment of alkyl halide with the alkoxide, sodium alkoxide. एक आपको बनाना one reagent, you will have to prepare like a sodium alkoxide, and the second reagent should be the alkyl halide. Okay, so these are the two reagents. Now the question is, write the names of the reagent and the equations. You have to write down the equations also for the preparation of this ether by the Williamson synthesis. So you will write down the name. Okay, you write down the name, or you can just show the equation. So these are the reactants, and what will be the what will be the mechanism over here? Okay, I've already explained it to you. So this oxygen has a lone pair, right? Now tell me, Aisha, you will tell me which one between this reagent is nucleophile and which one is the substrate. Because nucleophilic substitution में क्या होता था? There must be one nucleophile and the substrate, two components. Nucleophilic substitution reaction में क्या होते थे? There are two components. First one is your substrate, and the second one is a nucleophile, which attacks on the substrate. So just tell me, between this group, this A group and the B group, this compound, which one is your nucleophile and which one is your substrate?
A is nucleophile and B substrate.
Yes, very good. So nucleophile, you can see alkoxide, sodium alkoxide is the nucleophile. So nucleophile has a lone pair. Lone pair is negatively charged, electron rich होते हैं. So it will, and this bond, you can see this bromine and this carbon bond. So between this, there is a difference in the electronegativity. So this bromine is more electronegative than this carbon. So it must have partial negative charge, and this carbon will have partial positive charge. And this oxygen has a lone pair. So it will approach this carbon because this is a partial positive, and ये opposite को attract करेगा, right? So it will attack on the partial positive, this carbon. Okay, when it attack this nucleophile will attack on this carbon. Suddenly this bromine is a good living group, so ये leave कर जाएगा. Okay, and you will get this compound. So here the ether will be formed, oxygen. Okay, and yeah, and this sodium Na, this is Na plus, and this is oxygen will have minus charge. So Na क्या combine कर लेगा bromine के साथ, and you will get NaBr. So 1, 2, 3 carbon, and 1, 2, 3 carbon. Okay, 1, 2, 3. So it will attach this oxygen को आप कहाँ से attach करोगे? To this carbon, 1, 2, 3. So this is your corresponding ether. Okay, now you can check. Yeah, this is a one propoxypropane. So yeah, it's correct. Okay, so it's the required product. So that's how you have to do in your exam. If they ask you write down the names of the reagent, they will give you the product. Okay, and आपने break करना, you have to break the bond. Okay, and to the oxygen side. Okay, to this oxygen side, you have to attach the sodium. Okay, basically you have to make the sodium alkoxide over here plus the alkyl halide. Okay, the remaining fragment को आपने किससे attach करना है? Any halogen group. any halogen atom. So, and you know the mechanism, this is the nucleophile, so it will attack this carbon. And you can see this occurs in a single step. Okay, nucleophile ने attack किया इस carbon पे. Okay, and this bromine will left the group. So this occurs in a single step. If it occurs in a single step, so this type of substitution, nucleophilic substitution, is known as SN2 nucleophilic substitution. SN2 bimolecular. Okay, and यहाँ पे the byproduct will be NABR. Clear, Aisha and Muniba?
Yes, ma'am.
Yes, ma'am.
Okay, do the second, third, and fourth. If it is clear, just do that. Now see, if it is aryl type of this aryl group is over here. Okay, here's oxygen linkage, ether linkage on any one of the side or both the sides if the aryl group is present. So just be careful. If aryl group is there, benzene ring is present, so just be careful because this bond is involved. This basically this oxygen has a lone pair, right? So it is involved in the resonance. So this bond has a partial double bond character. यहाँ पे partial double bond character, due to that it is a stronger. It is stronger and it is very difficult to break this bond. So you don't, if the benzene ring are attached to this oxygen linkage, you can't break this bond. Okay, just be careful. So you can't break this bond. So ये bond आप break करोगे, not this one, not this one. So be careful over here. Now do this. And you should also know how to name the ether. So it's ethoxybenzene. If you don't know what is ethoxybenzene, so how you will draw the structure? How you will draw the structure, right? So this is your oxygen linkage, and this 1,2 carbon here. This is your ethoxy, okay, ethoxy group, and this is your benzene ring. So first, in this type of question, first you have to choose the parent chain, parent ring. So in between this benzene and this ethyl group, this has more number of carbon. Okay, and this is more bulky group. So you will treat this benzene ring as a parent chain. Okay, and you will and the remaining thing between this oxygen and this ethyl group, you will take it as a alkoxy group. Okay, it's just as a substituent आप treat करोगे. And this is the parent chain. That's why here it has been written benzene at the last. Okay, because parent का name हम क्या लिखते हैं, last पे लिखते हैं, just as a title. Yeah. So this is your benzene and this is your ethoxy. Okay? Oxygen with the ethyl. This is known as ethoxy. So it's ethoxy benzene. Done?
Yes, ma'am.
Yeah. So see. Okay, just match your answer. Is it correct or not? So you have to break this bond, oxygen and carbon bond. Okay, don't break this bond because this is very difficult to break due to the partial double bond character. So you will cleave this bond. When you cleave this bond, and so oxygen के पास अब क्या जाएगा? Sodium. Okay, just attach the sodium. So sodium will have the positive charge and this has a lone pair. Plus the remaining one, 2 carbon, 1, 2 carbon, and you can attach any halogen group. Okay, and now you can just show the reaction equations आप show करोगे. These two are the reactants. You can show the reactants, and if you want to write down the name of this one, if you can. Okay, so and this has a lone pair, so it will attack this carbon, and so you will get this one. O, and here 1, 2 carbon, 1, 2 plus your NABR. So that's the product. Clear, Aisha?
Yes, ma'am.
Now you can do this type of question. Or is there any doubt?
Ma'am, the third one.
Okay, third one. Yeah, again, it's very easy. So see, whatever is given, the R group is whatever. You have to just see the oxygen linkage. First, आपको क्या देखना है? This oxygen linkage. This is the oxygen linkage, and you have to see which group is present on the right side and on the left side of this oxygen linkage, ether linkage. So this is the methyl group, and this is the whole thing. Okay, this is your group. Now, how you will first thing is how you will cleave the bond. How you will cleave the bond. So it's very easy. It's very easy. This यहाँ से break कर दो and you will get this. When you will break this bond, see what I have teach you. See this point. If there I have not mentioned that. See, so you have to check this type of. Yeah. So see, this is oxygen. This is your alpha carbon. First of all, you have to check the alpha carbon. This is your alpha carbon. Okay, and again, this is again an alpha carbon. Alpha carbon वो होता है जिससे directly attached होता है this oxygen linkage. To this oxygen, this carbon is directly attached. So this is your alpha carbon. Okay, and here, why she left it? Maybe. Niba, your concept is clear, right?
Yes, ma'am.
So let's wait. Why she left?
But I still had doubt in this one, this bit.
Yeah. This question, third question.
Yes.
Okay, I will explain it. So see, this is your alpha carbon. This is again your alpha carbon. On the right side, this is your carbon, alpha carbon. This is again your alpha carbon. Yeah, now you have to check whether the tertiary alpha carbon is present or not. Tertiary alpha carbon. So you can see this is your tertiary alpha carbon. ये क्या है आपका tertiary alpha carbon? So tertiary alpha carbon will always form alkoxide. Okay, see this point. This point, it's clearly mentioned over here to form unsymmetrical ether, primary alkyl halide should be used preferably. So what does this mean? Alkyl halide should be primary, right? Alkyl halide should be primary. Now see, this is a group. So oxygen linkage, alpha carbon, alpha carbon. Now you have to check, this is your primary carbon, right? This is your primary one and this is your tertiary one. This is a tertiary one. So if you make this tertiary one as a alkyl halide, so it will be very hindered. यहाँ पे बहुत ही hindration आएंगे, right? So you have to break this bond from here. You have to break this bond from here because आपको क्या बनाना है? Alkyl halide, primary alkyl halide आपने use. Okay, so you have to whenever the primary alpha carbon is primary, so just bond यहाँ से break होगा and you have to make the alkyl halide from this primary group, not the tertiary one. Okay, again I'm repeating. See, this is your group. See, okay, now you can check oxygen यहाँ पे and this is alpha carbon and this is your alpha carbon. Now, this alpha carbon is more hindered. Why it is more hindered? Because here there are three bulky groups attached. Okay, यहाँ पे भी methyl है CH3 group. Here again methyl group and here again methyl is attached. Okay, this is the tertiary one. Okay, and this is your primary one. ओके सो इट्स वेरी इजी, जो प्राइमरी होगा उससे आप क्या बनाओगे, अल्काइल हैलाइड। ओके सो अल्काइल हैलाइड शुड बी लेस हिंडर्ड होने चाहिए, सो यू विल यूज प्राइमरी ग्रुप फॉर अल्काइल हैलाइड। सो you will break this bond. You will break this bond. Bond यहाँ से break होगा and you will make CH3Br. Okay, this primary alpha carbon से आप क्या बनाओगे, alkyl group. Now, why I don't use this group? यहाँ से मैंने क्यों bond break नहीं की? So there is a reason, because see this point. If you use usage of in the unsymmetrical ether, क्या होता है, usage of secondary and tertiary haloalkane leads to the formation of alkene. Leads to the formation of alkene due to more hydration. Due to more hydration. So that's why when you are preparing the unsymmetrical type of ether, you will always use primary alkyl. Primary alkyl halide if it is present in the ether. Clear, Aisha and Maniba?
Yes, ma'am.
Yeah, so that's why मैंने bond कहाँ से break किया, यहाँ से, and CH3 will make the alkyl halide, alkyl bromide, or anything you can take, chloride भी आप ले सकते हो. And to this remaining group will form the your alkoxide. So यहाँ पे क्या आप attach करोगे, sodium. So now 1, 2, 3 methyl group and here ON. So that's the cleavage. That's the reagent. First, this is the alkoxide, which is nucleophile, and this is the substrate, which is your alkyl halide. Clear, both of you? How you will break this type of bond, unsymmetrical one?
Yes, ma'am.
Moniba?
Yes, ma'am.
Yeah. Now it's easy. Now the mechanism तो आप बताइए आपने. So this will have the partial negative charge. This will have the partial positive charge. This oxygen will come. It will act as a nucleophile. So it will come and attack this carbon. And from here, this bromine, this bond will leave. And you will get 1, 2, 3 carbon, and here oxygen, and here CH. This is a product, and the byproduct is NaBr. Now do the fourth one. Each and every point is very, very important. Each and every point is very, very important. मैंने discuss किया था last class में, which we will use in this fourth question. So you can see here, there are two groups, methyl group and the ethyl group. Now the question is, आप किस group से आप alkyl halide बनाओगे? Okay, and which group you will use to make alkoxide, means nucleophile. Just quickly do that. Just think about it and do that. Do that. Yeah, so again, it's again an unsymmetrical type of uh, ether, right? So this is the first group. Okay, suppose this is the second group. First group and second group. Now the question is, second group we will use to make the alkyl halide or the first. So whenever this type of question comes, so just choose the small number of carbon to make the alkyl halide. To make the alkyl halide. So here the number of carbon is 2. Okay, so see, both are primary one. Both are primary one. Now the question is, दोनों ही primary है, so which group you will use to make the alkyl halide? So just choose the less number of carbon to make the alkyl halide. So you will make this as alkyl halide. So here the bond will cleave from here, oxygen and this carbon bond. So this second से आप क्या बनोगे? Second group you will use to make alkyl halide plus this remaining group 1, 2 carbon. Okay, so you will make OM alkoxide. So whenever this type of question can come, so just choose the less number of carbon to make the alkyl halide. Okay, so each type of question we have discussed, like when the group is alkyl or aryl. Okay, so mixtures and the miscellaneous questions we have already done. This one is very important question. Okay, so you have to discuss. Basically, you have to revise this after the class. Just revise the notes. Each and every point is very very important, and the practice more question. Practice more question. Then only you will be. The concept will be more clear. Okay, so just do the mechanism of Williamson ether synthesis. So again, this is a nucleophile. Okay, so this will attack this carbon and this will left, and you will get O and here CH3 plus your Na. Clear?
Yes,
Yes.
ma'am.
Okay, now the next question. Ditert butyl ether cannot be prepared by Williamson ether synthesis. Why? Why? Ditert. So first of all, just draw the structure of ditert butyl ether. It's a di and tertiary butyl ether. Okay, so first, this is your ether linkage, right? And it's di. दोनों ही side same group, and that's why it has been used di word. So tertiary butyl आपने बनाना. Tertiary butyl. So C carbon, here CH3, CH3, and CH3. So this is a tertiary butyl, 1, 2, 3, 4 carbon. Okay, tertiary butyl. And here also on the right side also you will draw the tertiary butyl. So this is your ditert butyl ether. Now, any one of you, please can you please tell me why cannot be prepared by Williamson ether synthesis? Why we can't use?
Because of the steric hindrance.
Very good. Okay, because as you can see, there are more bulky group present. Okay, because ये भी तो दो group से बना होगा. One the nucleophile means alkoxide, and the second one is your tertiary halide. Tertiary halide. So you know in the tertiary halide से आप बताते हो तो it will be elimination reaction instead of the nucleophilic substitution reaction. और elimination अगर होगा तो you will not get the desired product. You will not get the ether. You will get the alkene over there. Okay, because of more hindrance. You can see there are more ethyl group, more methyl group. So more bulky group present है इस वजह से क्या होगा there will be more hindrance, and due to the more hindrance you will not get the desired product. So that's why we cannot prepare this ditert butyl ether by Williamson ether synthesis. Okay, so because you can see this is the structure. So if you have to prepare this, so you will break this bond. Okay, and यहाँ पे क्या आप करोगे ONA, this is your methyl and methyl. Okay, so alkoxide group is again the tertiary one, plus this group means alkyl bromine. You can attach over here methyl group, and here the methyl. So this is again the tertiary one. Okay, so when this ditert butyl ether, when it is prepared by the Williamson ether synthesis, so there must be the reaction between the tertiary alkoxide and the tertiary alkyl halide. Okay, and you know very well tertiary alkyl halide हम किसे prefer करते हैं? Primary one. Alkyl halide basically in the Williamson ether synthesis, we prefer the primary alkyl halide, not the secondary or tertiary. Why not the secondary and tertiary? Due to the bulky group, more bulky group. Here in the tertiary one, you can see there are 3 methyl group present on this alpha carbon. Okay, so ये क्या करेगा? It will hinder the chemical reaction. Due to that, due to the steric hindrance and due to the bulky group, what happens? There will the substitution, nucleophilic substitution reaction will not take place. Instead of that, elimination will occur. Elimination reaction hoga, or elimination hoga, so you will get the alkene, not the desired product, which is your ether. So that's why ditert butyl ether cannot be prepared by Williamson ether synthesis. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yeah, so at last you can write down this point. This requires a reaction of tertiary haloalkane with tertiary alkoxide, which results in the formation of alkene. So that's why it is not possible. Now tell me, uh, what will be the reactant in this for this ether? Suppose this is your ether. Okay, this is the ether linkage, and here is a benzene ring, and here's again a benzene ring. Both side benzene ring is attached. Now tell me which bond you will break and what will be the reactant over here. And if this reaction is possible or not, just think about it. Yes, yes, Aisha. From where you will break this bond?
It won't be possible
Yes, why it is not possible?
because of resonance.
Yes, very good. Okay, so here you can see it is directly attached to the this benzene. So ये भी involve a resonance में. There must be a partial double bond character, and here also. So it is not possible for this to undergo nucleophilic substitution reaction. Okay, because you know very well halo yeah. For example, if you have to break this bond, so this requires ये कैसे बना होगा? This must requires the reaction of phenoxide ion with the haloarine with the haloarine with the haloarine. So ये कब बनेगा? When the reaction, the phenoxide, okay, when the benzene or your phenoxide ion will react to the haloarine. And you know very well, this Williamson synthesis occurs via nucleophilic substitution reaction. And in the haloarenes, the nucleophilic substitution reaction won't take place at normal temperature, right? It will take place, it is possible, but at a very drastic conditions, like when you give the high temperature and high pressure, then only the nucleophilic substitution reaction in haloarine is possible. Okay? And हमने पढ़ा है dose process. Dose process is the nucleophilic substitution reaction of haloarine at high temperature and high pressure. But normally haloarenes won't show nucleophilic substitution reaction. Okay, so that's why this reaction, uh, so this reaction, the nucleophilic substitution reaction is not possible, and you can't prepare this product using Williamson ether synthesis. Okay, because you can see there is a partial double bond character. It is involved in the resonance. Both the benzene ring is involved in the resonance with this oxygen. Okay, and due to that, it is very difficult to break both the bond. Any of the bond will not break. Okay, and the reaction of the Williamson ether synthesis will not take place. So you can't prepare this product using the Williamson ether synthesis. Okay, so so reason you can write in your exam. This will require a reaction of phenoxide with haloarine, but haloarenes haloarine don't show nucleophilic substitution reaction. Got my point?
Yes, ma'am.
Yes, ma'am.
And next, physical properties of ether. Physical, write down the heading. Physical properties of ether. So ether, basically, you can see this ROR group, it is known as ether. Okay, ROR group. So you can see it is a slightly polar. Now the question is why it is slightly polar. So polarity कब induce होती है? When there is a difference in the electronegativity. But here in the alkyl group there is a carbon. Okay, and again alkyl group में क्या है? Carbon. Okay, so between the carbon and oxygen there is a slight difference in the electronegativity. There is a slight difference in the electronegativity. Oxygen is more electronegative than carbon. Okay, so there must be a polarity. यहाँ पे polarity induced होगी. Okay, so the oxygen will get partial negative charge and the carbon of the alkyl group will will acquire partial positive charge. Okay, so due to that, it is polar, but not as compared to the your other group like your phenol or your alcohol. Okay, this is a slightly polar molecule. This is a slightly, the physical properties I first write down. This is slightly polar, slightly polar. Second point, ethers have lower boiling point than the alcohol. Ethers के जो होते हैं, they have lower boiling point than the alcohol. Why? Due to the absence of hydrogen bonding in ethers. Due to the absence of the hydrogen bonding in ethers. So in ether, there is the absence of hydrogen bonding. So that's why their boiling point is low. Okay, and as compared to the alcohol, because alcohol में क्या होता है, there is a hydrogen bonding present in the alcohol, and due to that its boiling point is quite high. And ethers से compare किया जाए तो ethers have lower boiling point. Now the boiling point of ethers is slightly higher. Boiling point of ether is slightly higher than the hydrocarbons. On the other hand, when you compare the boiling point of ether with the hydrocarbon, okay, so hydrocarbons, when you compare with the similar mass should be similar. The number of carbon should be same and the mass should be similar. So if you compare the ether and the hydrocarbon, so ether will have slightly higher boiling point than the hydrocarbon chain, with a similar molar mass. Next point is ethers are soluble in water. Ethers is soluble in water. Why? Because they can form. So they have, due to the absence, or they have absence of hydrogen bonding in itself. Okay, but they can form hydrogen bond with water because they are slightly polar. They are slightly polar molecule. So oxygen के पास क्या है? Lone pair. So when you dissolve the ether in the water, what happens? This water has a hydrogen bonding. You can see there is a difference in the electronegativity. Okay, hydrogen is attached to the electronegative element. Okay, so for the what is the condition for the hydrogen bonding? First condition is always, remember, hydrogen होना चाहिए, and hydrogen should be attached to the most electronegative element, either fluorine, oxygen, nitrogen. Okay, then only it will exhibit hydrogen bonding. Hydrogen bonding. So what happens? This oxygen has a lone pair, and this suppose between this H2O, this is a water. So this oxygen has a negatively charged partial negative charge, and this hydrogen will have the partial positive charge. Right? So this will have the partial positive charge. So when you dissolve the ether into the water, what happens? Oxygen is having the lone pairs है इसके पास, and lone pairs क्या होते हैं? They are negatively charged. They are non-bonded electrons. Electrons से तो होते हैं. So they will try to approach this hydrogen. Okay, and there will be a hydrogen bonding between the oxygen of the ether and the hydrogen of the water. So यहाँ पे hydrogen bond बनाता है. So that's why ethers are soluble in water. Ethers are soluble in water. Is it clear?
Yes,
Yes.
ma'am.
So increase in the number of carbon will decrease solubility. If you increase the number of carbon, so it will decrease the solubility, because the alkyl group, basically it's a bulky group, and it will hinder the solubility. Basically hydrogen bond बनाने में वो help नहीं करता, वो hindration करता है. So more the number of carbon, so less will be the solubility. So basically you can write down the number of carbon atoms in the ether is inversely proportional to the solubility. It is inversely proportional to the solubility. More the number of carbon, less will be the solubility, and vice versa. Yeah. So these are some physical properties of ether. So इससे क्वेश्चन बेसिकली क्वेश्चंस किस पार्ट से आते हैं? बेसिकली दे विल गिव यू the solubility condition. They will give you some ethers, some molecules, and they will ask you to arrange on the basis of the solubility. Okay, so just remember this number of carbon is inversely proportional to the solubility. More the number of carbon in the ether, less will be the solubility, and vice versa. Now, chemical properties of ethers. Chemical properties of ethers. So this is important. This is very important. So first reaction is when you cleave the CO bond, carbon and oxygen bond को when you break. So first reaction is reaction with HX. The reaction of HX में आपने क्या करना? You have to cleave the carbon and oxygen bond. Carbon and oxygen bond you have to cleave. First is your reaction with HX. Okay, your halogen acids. So treatment of ethers with the HX halogen acids leads to the formation of corresponding alcohol and halol. Okay, so when you treat the ether with the halogen acid HCl, HBr, okay, so you will get the corresponding alcohol plus the haloalkane Now again, we will talk about the symmetrical type of ether and the unsymmetrical type of ether, right? Symmetrical or unsymmetrical. It depends on the cleavage of the CO bond. Okay, so first one is your symmetrical ethers. Symmetrical ethers. Okay, please just try to understand this concept. This is important, very important. So first let's try to, let's see the general reaction of the reaction with HX. So when you take ROR, and when you add HX, so this will have the lone pairs. Lone pairs is इसके पास what it's supposed to, this will hydrogen will have the H plus. It will ionize to form H plus ion and X minus ion. Okay, because of electronegativity, X will acquire negative charge and this will acquire positive charge. So this oxygen is again has a lone pair. Okay, so यहाँ पे क्या होगा? This hydrogen and here. If it is symmetrical, so it's no problem. You can cleave any bond, any CO bond you can break. So from here, this will make OH. This high oxygen will approach this hydrogen and this R. ये क्या होगा? Is right? And here from here, the bond will cleave. From here, the bond will cleave. So it's for the symmetrical type of ether. If it is symmetrical type of ether, so you can either break this OR group or ये भी आप break कर any of them break करोगे, and to the oxygen you have always just attach the hydrogen because it's H plus, okay, and oxygen is negatively charged, so it will form ROH, alcohol. Okay, so from here alcohol will be formed plus the second one, this bond will break from here and ये क्या बन गया? New bond will be formed with X, so you will get RX, which is a haloalkane. So when you treat the ethers with the HX, okay, so you will get alcohol plus your haloalkane. Clear?
Yes, ma'am.
Yes, ma'am.
Okay, see, if you have any doubt, just ask me at that time. Okay, वो बात के लिए मत रखो pending कि मैं बाद में पूछूंगी. Just clear your doubts at that. Okay?
Okay, ma'am.
Symmetrical ethers. Now, again, it's very easy. It's a symmetrical, so you can cleave this H will have plus charge, minus charge. The oxygen के पास क्या है? Negatively lone pair. So you can cleave any bond. Okay, this is if it is a symmetrical, so you can cleave any CO bond, either this one or this, and HI. So H will combine with this oxygen and carbon will combine. The CH3 group will combine here and this bond will cleave. And you will get CH3OH methanol plus CH3I. Okay, methyl iodide. So that's the product. It's for the symmetrical one. That's how you will cleave the CO bond and you will get corresponding alcohol plus your halol. Okay, now do these questions, second and third. And
Yes, ma'am.
okay, Muniba, tell me the answer.
CH3 CH2 OH plus CH2 CH3 HBr minus.
This will be your product. So this is your ethyl alcohol or ethanol, you can write ethyl alcohol, and this is your ethyl bromide. Ethyl bromide. Yes, Aisha, third one.
CH3, CH2, OH, CH3, CH2, CH3, I.
So basically, you can break this bond from here, hydrogen, and इसके साथ क्या attach हो जाएगा? Iodine. So you will get this one. Can you please tell me the name of this, Aisha? Iodine. What will be the name of this product? The iso group, isopropyl. So when you see this type of your Y shape, इस type का आप देखो, so it's the iso group. So it's a iso, right? So 1, 2, 1, 2, 3. Okay, so iso group में आप combine करके बोलते हो 1, 2, 3 carbon. So it's a propyl. So isopropyl alcohol. So its name is isopropyl alcohol. And what is this, Aisha?
Isopropyl iodide.
Yes, isopropyl iodide. Okay, so symmetrical one is very simple. It's very simple, but the main thing is unsymmetrical ether. Okay, this is conceptual and this is important. Unsymmetrical. Okay, so unsymmetrical ether. When in your exam, they will give you unsymmetrical type of ether, and the reagent is your halogen acid, HBr or any HCl, HI, anything. So you have to check if there is any tertiary alpha carbon or not. Tertiary alpha carbon present hai ya nahi, you have to check. So see, first of all, first question. Let's see step by step. This is the oxygen. Okay. So on the right side, this is the alpha carbon, right? And on the left side, this is the alpha carbon. This is the alpha carbon. Now check it. Which alpha carbon is tertiary? Tertiary alpha carbon. Which one? You can see this is your primary alpha carbon. Okay, कैसे आप primary secondary tertiary करते हो? This is a carbon. Okay, and this carbon is further attached to only one group. Okay, further किससे attached to only one group, which is CH3. So this is the primary. But here this alpha carbon से कितने attachments हैं? 3. 1, 2, 3. 3 methyl group is present, means this is the tertiary alpha carbon. Okay. So first of all, whenever there is an unsymmetrical type of ether, and you have to treat it with the halogen acid. Okay, treatment आपका reagent is given as a halogen acid. So you have to check if there is any tertiary alpha carbon or not. Okay, if there is a tertiary alpha carbon, so attach the halogen group. Halogen group, this bromine group, आपको किससे attach करनी है? Tertiary alpha carbon से. and the remaining fragment will form the alcohol. Okay, so in this one, this is the tertiary one. So from here, the bond will be break. और ये क्या बनाएगा आपका halogen. Yeah, इससे you have to attach the halogen 1, 2, 3. Okay, and to this you have to attach the Br. Here the Br is given, HBr is given, so halogen you have to attach to the tertiary alpha carbon. Plus this remaining group CH3, CH2O. This is the remaining group CH3, CH2 and O. So it will form hydrogen. So hydrogen will come and attach to this oxygen and it will form alcohol. That's what we have to do in the unsymmetrical type of ether. Okay, again I'm repeating. First we have to check if there is tertiary alpha carbon or not. If there is a tertiary alpha carbon, so it's very simple. Just attach the halogen to that carbon. Okay, so you will get the tertiary alkyl bromide. Okay, tertiary alkyl halide. Plus the other fragments, the remaining fragment will form the alcohol. Means उससे आप oxygen को क्या attach करोगे? Hydrogen, and you will get the alcohol over there. Okay, clear,
Yes,
Aisha and
ma'am.
Mahima?
Yes, ma'am.
Yes.
Do the second one. First step, find the tertiary alpha carbon. This is the alpha carbon, the left side, and this is on the right side. Suppose this is a alpha 1 and this is a alpha 2 carbon. Now tell me which alpha carbon is tertiary? Aisha.
Alpha 2.
Yes, alpha 2 is tertiary. So you have to break this bond from here and you have to attach this iodine which have negative charge and this will have the positive charge. So आपको iodine किससे attach करना है? This alpha 2 because this is a tertiary. This is your primary. So you will get CH3. The CH3 मैं इस side से लिख रही हूँ CH3, CH2 carbon and your iodine CH3, CH3. Plus the remaining fragment will form the alcohol CH3, CH2, CH2 and OH. You will get propanol. Okay, it's clear now?
Yes, ma'am.
Okay, now let's see the mechanism. What will be the mechanism of this reaction? Means when you treat the ethanol or your ether with halogen acid. So what will be the mechanism? So suppose if you take the HI आप ले रहे हो. Okay, I'm just showing the mechanism of this reaction. First one, इसका mechanism मैं share कर रही हूँ. So mechanism, first one HI. So HI will dissociate this halogen acid. It will dissociate in and it will give you H plus plus I minus. I minus because iodine is electronegative and the hydrogen is electropositive. So this will pull the electron density towards itself and इसके पास क्या आ जाएगा charge? Negative charge. This hydrogen will acquire a positive charge. First step. Second step. Though this is your ether. One. Yeah. So this has a lone pair. This ether has a lone pair and this hydrogen H plus ion यहाँ पे protonation होगा. Second step में the protonation of ether. Okay, protonation. This oxygen has a lone pair, so it will approach this hydrogen H plus ion and यहाँ पे क्या form करेगा? This O2. Okay, and here the hydrogen will come and attach it. So here the protonation of this oxygen. Okay, why this positive charge over here? Because oxygen के पास दो ही bond बना सकता है, right? But here the three bonds are there, so that's why यहाँ पे positive sign global. Now what happens? Because this is very unstable bond. This is very unstable. So what will happen? यहाँ से ये bond break हो जाए. This bond will shift over here and this bond will break, and you will get this will when this will break, this bond will break. You will get alcohol. No, sorry. When this bond will break, you will get alcohol OH. And यहाँ पे क्या बनेगा? इसका carbocatan will be formed. 1, 2, 3. Tertiary carbocatan will be. See, you have to break this bond. यहाँ से break हो गया bond, so you will get 1, 2. Okay, 1, 2 carbon and OH group, which is your ethanol. You will get ethanol plus this will give you this remaining fragment. This will give you a carbocatan. This will form carbocatan. And tertiary carbocatan, it's very reactive. Tertiary carbocatan, it's very reactive, right? So what happens over here? So we have iodine minus ion also. यहाँ पे हमारे पास iodine minus भी है. So it will attack this tertiary carbocatan, and you will get this one. So that's the whole mechanism for this reaction. So you can see the product you will get is alcohol plus this one. Alcohol plus this one. Clear?
Yes, ma'am.
Yes.
Yeah. So please write it down. The mechanism. First step में ionization of halogen acid. Okay, then the second step is the protonation of this oxygen. And the third step is the cleavage of the bond to give you the alcohol and our cleavage of the bond, and you can see you can also call it as a formation of carbocatan. Here the carbocatan will be formed, so the iodine will come, I minus will come and attack the carbocatan because tertiary carbocatan is very very reactive. So ये reaction बहुत fast होगा and you will get the this product. Tertiary alkyl halide. Okay, alkyl iodide. Now see, if only primary and secondary alpha carbon are present. Okay. Now यहाँ पे the question था, you have to check whether the tertiary carbocatan is there or not. Okay, if it is there, then you have to attach the halogen to that tertiary alpha carbon, and the remaining fragment they will form the alcohol. Now the question is, if the tertiary alpha carbon is absent, if there is no tertiary alpha carbon, so what we are supposed to do? So if only primary and secondary alpha carbon are present, then the alkyl group, which is which is less hindered, will get halogen, and the rest of the fragment will form alcohol. So you have to, yeah, this is important. So when the primary and secondary alpha carbon present over, then you have to check which alpha carbon is less hindered, which is less hindered. So you have to attach the halogen to the less hindered alpha carbon. Okay, and rest of the fragment will form the alcohol. Okay, now let's do some questions. So you can check over here. So this is oxygen. So here, this is the primary alpha carbon. This is the alpha carbon. Okay, and this is the second alpha 1, alpha 2. This is your primary alpha carbon, but this is a secondary. How you will check the secondary? This is the carbon and there are two groups. One group directly आपको देखना है. Directly कितनी groups attached है? So 1 and 2, right? So this is your secondary alpha carbon. Okay. Now you can see which one is less hindered. So obviously the primary one is less hindered. Primary alpha carbon is less hindered because secondary में क्या है? There are two methyl group. Here methyl group और यहाँ पे methyl group और ये भी attached. So here the number of carbon is more, okay, and there is more hydration in the alpha 2 on the alpha 2. So that's why you will attach the halogen, okay, iodine with this alpha 1 position because this primary alpha 1 carbon is less hindered. So you have to break this bond, not this bond. Okay, so इससे क्या बनाओगे आप? 1, 2, 1, 2 and iodine will attach over here. Plus the remaining part, the remaining one will form the alcohol. So alcohol will be this. Is this concept is clear?
Yes, ma'am.
Yes, ma'am.
We do the second one, second and third. Then,
Yes, ma'am.
okay, Aisha, tell me the first answer. The second one.
CH3CH2OH plus CH3Br.
Okay. CH3Br plus your ethanol. Yeah, good. So this is less inert, so you will break this bond from here and CH3 is attached with the bromine and the remaining will form the. Yes, Muniba, last one.
CH3, CH2, CH2OH
Yes.
plus I with
Yeah. Okay, so I think it's clear to everyone. Okay, alkoxybenzene. Okay, so alkoxy, whenever the benzene word come in the ether, so be careful while the cleavage of bond. Okay, so this bond will not cleave. Okay, so obviously यहाँ से break होगा. Okay, you know very well what is the reason why this bond will not cleave. So alkoxybenzene always forms phenol and haloalkane. Alkoxybenzene क्या बनाता है? Phenol and the haloalkane because the CO bond on the phenyl has double bond. This has a double bond character and this is very difficult to break. So you are not supposed to break this bond. आप ये bond break. Okay, and when you break this bond, so H plus will come and attach on this oxidation because it has a lone pair on this alkyl group which is having a positive sign. So iodine which is having negative sign, so it will come and attach and bond यहाँ से break होगा and you will get OH which is phenol plus your RI, okay, alkyl iodide. Okay, so it's very simple. So whenever the benzene ring come, okay, in the ether part, in the ether question, just be careful. You don't have to break this bond. ये गलती कभी मत करना. Okay, so this bond will never break because it is very difficult. It's involved in the resonance. It has a partial double bond character. Due to that, you can't break the bond. Okay, so always break this bond. So do this question. First one, second question. Yeah, do this one. Only one question. It's more than enough. So what you're supposed to do, यहाँ से bond break करोगे and this hydrogen will attach on the oxygen and it will form phenol plus the remaining part, this one, 1, 2, 3, 1, 2, 3 carbon. And on the second carbon, आपको ये देखना है, this 1, 2, 3 carbon. And here on the second carbon, you have to attach the bromine. Not on the first or second, first or third. See, on the second carbon, you have to, yeah. So this will be the will be your product. Phenol plus your alkyl halide. Okay. Next one is your benzyl alkyl ether. Okay, so what is benzyl group? In the I think haloalkanes mein we have already discussed that. What is benzyl group? When the any group, okay, हमने haloalkane में ये किया था when the X group, halogen group. So here we are talking about the ether. So when the ether group is attached first to the sp3 hybridized carbon and this sp3 hybridized carbon is further attached to the sp2 benzene ring to the benzene ring. So it is known as benzylic ether. इसे हम क्या कहेंगे? Benzylic ether. So we are talking about the oxygen over here. This oxygen. So oxygen is the ether linkage. When the ether linkage say first it is attached to the sp3 hybridized carbon and this sp3 hybridized carbon is further attached to the benzene ring. So this type of system or ether is known as benzyl ether. Benzyl ether इसे हम कहते हैं. And the benzylic carbon is this. Benzylic carbon is this. Just remember benzylic group is very reactive. This is very reactive. Okay. So what happens over here now? So this bond, okay, यहाँ से आप bond break करोगे. This benzylic carbon के बाद जो ये है, this oxygen, this carbon and oxygen bond you will break in the benzyl alkyl ether. Okay, so always remember in the benzyl alkyl ether you will cleave this bond. ये जो benzylic carbon है, this benzylic carbon, So this carbon, benzylic carbon and oxygen bond will break, will break. So you will get, okay, so this will acquire negative charge. This will have the negative, yeah, lone pair. So hydrogen will attached here. And this iodine will attach to this. So it will give you CH2 and iodine plus CH2 iodine plus your ROH, alcohol. So this will be your uh, reactant. Okay, product आप कह सकते हो. This is your product in the benzyl alkyl ether. Benzyl alkyl ether. Basically, this will break down into the this group plus your alcohol. So in benzyl alkyl ether, just always remember you have to cleave this bond. ये benzylic carbon की बाद का जो bond है, you have to break this bond, not this one, not this one. Clear?
Yes, ma'am.
And can you explain again?
Yeah, sure. Now see. See, this group is known as benzylic group. When any group like your halogen, when we talk about the haloarenes, haloarenes. So what is haloarenes? When the halogen group is attached, when the halogen group is attached to the benzene ring, directly to the benzene ring. Suppose we have a X group, any halogen group. Okay, when the halogen group is first attached to the sp3 hybridized carbon, this is sp3. If you see a single bond, only single bond present hai, so this is a sp3 hybridized. Okay, when only single bond, कार्बन कार्बन के बीच में सिंगल बॉन्ड है, so this is your sp3 hybridized. If you see one double bond, all are single bond, but if you see one double bond, so the hybridization is sp2. Hybridization is sp2. If you see either two double bond or two, अगर आप देखो two double bond or only one triple bond. So the hybridization in this case is sp. sp हो जाता है hybridization. So to understand the benzylic type of ether, you have to understand the hybridization. What is hybridization? So if you see the carbon single bond hai, so the hybridization of that carbon is sp3. And if you see the double bond, like this is carbon and ketone. Okay, so and here suppose this is a CH3, this is a CH3, this is acetone. Okay, this group is acetone. Okay, propanone hota hai basically, and common name is acetone. So if I talk about the hybridization of this carbon, so you can see one single bond, but there is a double bond over here. एक double bond भी है. So if you see one double bond, others are single bond, but अगर एक one double bond दिख गया, so it means the hybridization of this carbon is sp2, not sp3, sp2. Aisha, clear?
Yes, ma'am.
Yeah. And if you see two double bond, like here, two double bond present is carbon के पास. Okay, so its hybridization is sp, only sp. And if you see carbon and suppose nitrogen, this carbon and nitrogen bond, so you can see there is one triple bond present है यहाँ पे. So carbon का hybridization क्या हो जाएगा? It's s. Okay, so just remember this. If you see single bond, so its hybridization is sp3. If only one double bond, अगर one double bond देखी आपने, तो it's sp2. It becomes sp2. And if two double bond or one triple bond is present, double bond होगा तो भी sp hybridization, and one triple bond is present, then the hybridization is again the sp hybridization. Right? Now, come to this one. Okay, see here, the halogen, this is the X halogen is attached to CH2. So this is sp3 hybridized carbon. Okay, and this further is attached to the benzene ring. This further is attached to the benzene ring. So this type of group is known as benzylic group. इसे हम क्या कहते हैं? Benzylic group. So here यहाँ पे क्या है, halogen नहीं है, यहाँ पे ether है. Here the group is ether. So here the oxygen linkage is present over here. So oxygen linkage है, and here this oxygen is attached first to the sp3 hybridized carbon, and it is further attached to the benzene ring. So this is known as benzylic ether. Benzylic ether. Clear, Aisha?
Yes, ma'am.
So benzylic ether. So whenever the trick is, you have to remember the trick here, how you are supposed to cleave the bond. So when the benzylic alkyl ether is present, means यहाँ पे आप देखोगे ether, okay, this is oxygen is the ether linkage, and here you will see this group CH2. It is first attached to the sp3 hybridized carbon, then it is attached to the benzene ring. अगर आप ऑक्सीजन के किसी भी साइड, any of the side, like right side or left side, if you see this group, first, sp3 hybridized carbon, it is attached to the CH2 group, single bond. So it's sp3 hybridized, and after that, it is attached to the benzene ring. अगर आप इस टाइप का attachment देखो, so this is a benzylic type of attachment, and this is the benzylic carbon. This carbon is known as benzylic carbon. So you have to break the bond from here. This CO bond breaker, and not this one. This, not this one. Okay. So you have to break this CO bond. Is it clear?
Yes, ma'am.
Now, when you just cleave this bond, so this oxygen has a lone pair, right? And this HI, this it will dissociate to form H plus and I minus, right? So the oxygen has a lone pair, so it will approach this hydrogen because this hydrogen is positively charged, and this oxygen is negatively charged. So this will यहाँ पे क्या होगा, ये कार्बोकैटायन फॉर्म करेगा. This benzylic carbocation will be formed, and benzylic carbocation is most stable. It's most stable and reactive. That's why you have to break this bond, CO bond. Okay, so when this bond will break, so this will acquire negative charge. This oxygen has a lone pair, and this will form carbocation. यहाँ पे plus charge आ जाएगा. Okay, and when the carbocation is there, benzylic carbocation is very reactive. So this iodine minus, this I minus, will come and attack this CH2 group, and it will form CH2 iodine plus this ROH. ROH. RO के साथ क्या हो जाएगा? Hydrogen. So it will form the alcohol, and the remaining group will form this benzylic iodide. Now clear, Aisha?
Yes, ma'am.
Muniba, is it clear?
Yes, ma'am.
Okay. Now do this question. Do these two examples. Which bond you will break? So oxygen, right? This is a benzylic carbon, CH2, and then your benzene group. So you will break this bond, this CO bond. Okay. So this will have the partial positive charge, negative charge. So hydrogen इसके पास जाएगा, and the iodine will form this. So the product will be benzene, CH2 group, and here iodine plus this whole thing, the remaining fragment, 1, 2, 3. Okay, so here OH. This will form isopropyl alcohol. Clear?
Yes, ma'am.
Yes, ma'am.
Okay, second question. So here the phenyl ring, okay, CH2, oxygen, and CH. Okay, so आप ये structure ऐसे भी draw कर सकते हो. This is the same thing. Okay, so from here, from where you will break the bond. So this is the oxygen linkage. This is the one benzyl group over here, and here CH2 benzene. CH2 benzene. Now it is not possible to break this bond. Okay, because it is involved in the resonance. Okay, it's very difficult to break this bond because यहाँ पे partial double bond character. So you have to break this. Okay. So here it will form benzene ring CH2 and इसके पास क्या जाएगा iodine plus it will form phenol. Okay, O and H. Phenol plus this one. So that's the product. Clear?
Yes, ma'am.
Yes, ma'am.
Okay, so benzyl halide is formed as a reaction occurs via SN1 and the benzyl carbocation is very stable, right? So here, why the bond has been broken from here, this CH2 oxygen to form the stable carbocation. And benzyl carbocation is most stable. Tertiary carbocation से भी ज़्यादा stable होता है हमारा benzyl carbocation. Okay, so just remember this. So that's why to make the carbocation stable carbocation, यहाँ से bond break होगा, so that carbocation is formed. Okay, because SN1 it occurs via SN1 mechanism. Or unimolecular nucleophilic substitution reaction occurs in two steps. First step will be the formation of carbocation. Second step will be the attack of nucleophile. So you can see first step में क्या हो गया यहाँ से bond break हुआ. There will be a formation of carbocation. And in the second step, this iodine will act as a nucleophile. It will come and attack the carbocation and it will form this one, your halide. Now, the next one is your diaryl ether. You will cleave the diaryl ether. Again, it is not possible. Yeah, again, it is not possible because both are involved in the resonance. So there is a partial double bond character. There is a partial double bond character between both the benzene and oxygen. So diaryl ether don't show this reaction, the reaction with HX, because both CO bond are partial double bond character, right? Both has a partial double bond character. Both are involved in the resonance. Okay, so that's why it is very difficult to break the bond, the CO bond. So there will be no reaction. Okay, so diaryl ether don't react with halogen acid to form the corresponding alcohol plus your alkyl halide due to the partial double bond character. Here,
Yes, ma'am.
if in your exam, if they just sometimes they will give you this compound, okay, and they will give you HI and write down the product. So in this case, the product you won't there will be no reaction. So you will write clearly there will be no reaction, no reaction. Okay, reaction is not possible. And in one point, आप यहाँ पे sentence लिख सकते हो why it is not possible. You can write down the reason also. So diaryl ether. Okay, so electrophilic aromatic substitution reaction of anisole. So we will cover this in the next class. Okay, we will cover this in the next class because time knows. So if there is any doubts from today's session, you can ask. Just clear your doubts. Everything is clear, Aisha and Muniba?
Yes, ma'am.
Yes, ma'am.
Okay, so in the next class, I will complete this chapter. Okay, and if possible, अगर ये 1 hour में complete हो जाता है chapter, so in the same class, I will start with a D and F block element. Okay, and the next chapter is D and F block.
Okay, ma'am.
All right, ma'am.
Okay, bye bye. Take care.
Thank you, ma'am.
Thank you.
Ma'am,
Yes, Muniba.
can you please let me know the question for the upcoming test? Like,
Okay, upcoming test. Yeah, it's still. Let me check. Send this labels to the demo. Yeah, the methods of preparation of alcohols is coming. Method of preparation of phenols, physical properties of alcohols, chemical properties of alcohols, and chemical properties of phenols, till method of preparation of ethers is coming. Till method of preparation of ethers, it's coming in your test. Okay, Maniba?
The one they sent us is method of preparation from alkenes. That comes under alcohols itself, right?
Yeah, yeah. So
Okay.
from the method of preparation of alcohol till the method of preparation of ethers. Have you got the notes? Did I share the notes, Maniba?
You
Till
did
method of
share
preparation. Till the method of preparation of ethers. Just check it out.
1 minute. Oh, yes, ma'am. You sent me method of preparation of it.